Okay, let's read this question. Adam Goodman determines that when X thousand units of his product are produced each month, let me highlight this. So this is the demand. Okay, they will all be sold at a price of, and then we have the price per unit. So it will be given in dirhams per unit. So also here when you replace X, it's in 1,000 units. So when you replace, even if you put 10 for X, this means the price if you produce 10,000 units. Okay, but just for simplicity, we put 10, but we mean 10,000. Okay, so that is the thing at the beginning to notice. Then the total monthly cost of producing the X units will be, and then they give us the cost function. So we expect what's going to happen. Okay, either they will ask about the revenue or the profit. So in this case, we see that they're asking about the maximum profit, things about it. So notice here that they want to know how many units should Adam produce in order to get the maximum possible profit. Then what is the maximum profit in this case? So you know the number of units that will give you the maximum profit. Now replace that number in the profit function that we will now write and get what it is. And last thing is find the price P. This is little p. Remember, the profit function is the one that's big P of X. That is the revenue minus the cost. And the price demand function, this one, we always write it as little p of X, and then the formula will be given to you. Always. But for the profit, no, they don't give you the formula because you need to know it's the revenue minus the cost. And in this case also, if you look here, they didn't give you the revenue because we know from the price demand function how to get the revenue. So the revenue R of X equals X, so the number of units produced times the price per unit. That gives you the revenue. Makes a lot of sense. So now, how about I take all of this away so we can focus better and just focus on each one at a time. So now I'm focusing on P of X. So X times P of X is X times, and now P of X, look at it, it's 22.2 minus 1.2x. And so this will give me 22.2x minus 1.2x squared. This is my revenue function. Of course, it's given in 1,000 AED. Okay, just like the cost, of course. The revenue, cost, and profit are all in the same units, of course. So now that's the revenue, and they want us to maximize profit, remember? So we need to get the profit. So now you can say, therefore, the profit function, or the total monthly profit function, equals P of X, or let's not put equal, just call it P of X equals, now that is the revenue minus the cost. Always it will be like this. And the revenue, we just got it here, 22.2x minus 1.2x squared minus the cost, which is, they gave it to us at the beginning, 0.4x squared plus 3x plus 40. And if you do this subtraction, notice 22.2x and minus here, minus 3x. 22.2 minus 3 is 19.2. So this will be 19.2x. This way you are done with these two. And now minus 1.2x squared minus 0.4 x squared. These two together, it will be minus 1.2 minus 0.4 x squared. And these, if you add them, you'll get minus 1.6 x squared, and so you're done with these, and you're left with the 40 and the minus outside, so minus 40. Perfect. So now this is our profit function, and it's also given in thousands of dirhams. So thousands AED, let's write it like this. The units for this, and it's also the units here for the revenue. Perfect. So now we have the profit function, and they want us to find the x that will maximize it. This is the function here. So our job, let me just write it so you understand, is what are we asked to do? Our job now is to maximize this profit function. Okay, so this is the profit function, and we will take its derivative, p prime of x. What do we get? So it will be 19.2 minus, you see, when you multiply 2 times 1.6, that will be 3.2x, and then the 40 gives you 0 because it's a constant. Set it equal to 0. This means that x will be 19.2 over 3.2. And this is equal to, so let's see, 19.2 over 3.2. I think it's 6, but let's check. Okay, so 19.2 over 3.2. 6, yeah, perfect. So this is 6, and you know that this means 6,000 units. Yeah, because the units are in thousands. So when you get 6, it does not mean he produced 6 things, but 6,000 things. And how did I know this? Is because at the beginning told me x thousand units. Whatever x you get, it's in thousands of units. So what this is telling us is that first, why is it a point that you have a maximum at? Let's just check. If you do the second derivative test, the second derivative of this is just minus 0.32, which is, I mean, the second derivative of p, which is the first derivative of p prime, is always negative. So this means that the function, the profit function, is always concave down. Concave down like this. That's when the second derivative is negative. So at x equals 6, we know that it's a place where the derivative is 0, so we have a horizontal tangent, and we know that it's concave down at this point, so it must be a maximum here. The point 6 comma p of 6 is where we have the maximum. Of course, if the second derivative was positive instead, if instead this was positive, then you know that the function will be opening this way, so concave upwards. And so if you have a critical value, a critical number for which the derivative is 0, it will be a minimum when the second derivative is positive. This is the second derivative test. It's a very nice way of quickly checking. Sometimes it's faster than doing the first derivative test. So in any case, now we know that this is a maximum. I will just erase the reason. And so now we know that, therefore, at x equal 6,000 units, the profit is maximum. P of x has its maximum value. Has its maximum value of, just replace 6 for x and p. And where is p? This is the function p here, p of x, you see. So just replace 6, 19.2 times 6 minus 1.6 times, so instead of x, 1 times 6 squared minus 40. And so let's see, this is here is 6. I'll get the calculator to check, and then I'll show you the graphs. So 19.2 times 6 minus 1.6 times 6 squared minus 40, 17.6. So 17.6, that's the profit. 17.6. In what is the profit given? Just like the cost and the revenue, the profit is given in 1,000 dirhams. So this 17.6 thousand AED. Okay, so here is the maximum is at x equals 6, and the value is 17.6. So if you want to speak it in terms that are relative to Adam, you will tell him that, Adam, you will reach your maximum profit when you are producing 6,000 units per month, and the profit in this case is going to be 17.6 thousand dirhams, like this, 17 times 600, like this, dirhams. This monthly, that's the maximum profit. And it happens when the production is 6,000 units. So that is the right amount to produce in order to maximize the profit. Okay, good. So now we solved A and B, and now C. What would be the price P? This is little p, the price demand here, when we have maximum profit. So all what you have to do is here, for part C, you'll go to the price demand and substitute 6. Because at 6 we have the maximum profit. So they're asking you now, what is the price at this X? So how much should we sell each unit in order to get the maximum profit? So you'll do 22.2 minus 1.2 times 6, which is, and we'll do it now, put the calculator here, so 22.2 minus 1.2 times 6 equals 15. 15 what? Dirhams per unit. Always the price demand function is in how much per each unit of what the company is producing. Very nice and very simple. You see, we solved the question now. So the first one here, x equals 6, then the profit at 6 is, and we got it somewhere down here, 17.6 thousand here. So this will be 17.6 thousand dirhams. Okay, this is 1,000 AED, and this is 1,000 units. Okay, and last one, the little p. Notice this is little p at 6, and the previous one was big P. Big P is the profit, little p is the price from the price demand. And we just calculated it here. It was 15 dirhams per unit. So I'll just summarize it immediately. What would Adam conclude? That when his company produces 6,000 units, this is when his profit will be maximum, and it will be 17,600 dirhams for that month. And in order to achieve it, the price for each unit should be 15 dirhams a unit, whatever he's producing. You see, I didn't really tell you what he's producing because it really doesn't matter. You can think of anything. Yeah, but what matters is the process that you solve the question with. I just want to show you in Dismos now everything that we've done. So first I will do the price demand function, 22.2 minus 1.2x. That's the price demand. Then the cost function, 0.4x squared plus 3x plus 40 Please pay attention to this, because this will make a lot of sense for you and make you understand it much better. Then the revenue, we computed it at the beginning, if you remember. It was here. So I'll compute it. 22.2x minus 1.2x squared. Okay, and notice the colors. The price demand red, the cost blue, the revenue green, and now I will add the profit. The profit, we got it here. This is the formula. So 19.2x minus 1.6x squared minus 40. Okay, so I put all of them, but really, which ones are we interested in? We wanted to maximize the profit. So let's remember, the profit is this one, the purple. So look at the purple graph now. Forget the other graphs, just the purple. The maximum of the purple, let's see where it is here. Yes, at 6, 17.6. Nice. And if we draw the line x equals 6, just to check where it's hitting the other things. Okay, so let's do like this. And now, watch careful. And remember the colors. Yeah, so I'm going to make it big like this so we see it clearly. At x equals 6, the price is the red. So see, 15 dirhams. That's when the profit will be maximum. So at x equals 6, the profit function is maximum, and the maximum profit is 17.6 thousand dirhams. And if you go to the red curve, that is the price demand function, you see that it's touching at 15. So this is telling you that if you want to get the maximum profit, then you sell your units at 15 dirhams a unit. If you do this, then the profit will be maximum. Otherwise, if you go to any other point, it will not give you the maximum profit. The maximum profit is only at the point where x is 6. So when you produce 6,000 units. Okay, and of course, if you want to see all of them at 6, so at 6 we have the first, let's do the revenue is the green. So the revenue is 90,000. Let's do all of them. Yeah, the revenue is 90,000. The cost is 72.4 thousand. The profit is 17.6 thousand. Notice now 17.6 plus 72.4. That's the cost and the profit. If you add them, you'll get 90, which is the revenue. And if you want the price when you produce 6,000 units, you go to the red curve. The red curve is the price demand function, and check. You'll see that you need to sell for 15 dirhams per unit. Very nice, and I will stop here.